So what we've got here, examples of relays. I've got two examples really. Got a 12 volt coil and a 5 volt coil. These two are the same. I'm going to play with those in a minute and show you how they work before they're actually connected into our circuit. I've got my 5 and 12 volt regulated power supply. I'm going to be using that for both sides of the circuit. And this is my 12 volt load. It's just an LED strip. Now, the first thing I want to show you is how to actually use a relay without connecting it yet to a circuit. Now, if you turn it upside down, just use these two for comparison. You see, sometimes you get a relay that has markings on its backside, so you can see which pins connect the coil and then which ones make up the secondary part of the relay. In other cases, you don't have any markings at all, so you'll have to do a bit of investigation to figure out which pins are which. So I'm going to use my multimeter. I'm going to set it to continuity testing and put that aside for now. I'll use the one with the markings first. So if I connect one electrode to, say, this side and the other one here, you can see that at rest, when the coil is not energized, these two pins make up a circuit. But this one is hanging up in the air, right? So no connection here. When the coil is energized, then this pin and that pin will be connected, and that pin with this pin will not be connected. Similarly, with the unmarked one, you can follow the same process to figure out which of the pins are connected at rest. Right? So these two are connected at rest. That's not connected at rest. Now, another thing you need to do is to figure out which pins make up the coil. This package has the schematic, so it's obviously that and that pin that make up the coil. This one isn't. I suspect that these two make up the coil. So to detect that, you use the resistance measurement tool on your multimeter. Now, the resistance between coils is fairly small, so it would be less than 200 ohms. So if I connect these two pins together, then, then I get, say, 72 ohms resistance between the two coils. Anything else that has infinite resistance. So if I wanted to check these two, no resistance, infinite, so no connection. There's no connection between these two either. If I try these two, I get about 0.7 ohms. So these two are obviously connected. That's why the continuity tool beeped earlier. So in the 5 volt relay, I know that this and this pin make up the coil. So how about we apply some 5 volt power and see what happens to the coil. So I'm going to get my 5 volts from the Arduino. So use couple of wires to do that. So there's ground, and I'll put my ground on this side. So now if doesn't really matter because it doesn't matter how you connect the wires to the relay because the relay is not a polarized device. So you can listen, you can hear the clicking sound, which means that the coil is energized every time that I close the circuit. Right, so these two are connected via the coil. Now I'm doing this with a little bit of a risk involved. You can probably see the little LED here flickers when I make the connection. An indication that there's a bit of current draw by the coil. So that tells me that I may be putting too much power through the Arduino. I'm actually drawing too much power from the Arduino to energize the coil. So in most cases, you should not do what I just did. You might end up burning the the Arduino. So you need to calculate how much current the relay is going to draw and then provide enough power to satisfy that demand. So how do we do that? Well, we're going to use Ohm's law. To calculate power draw, you need to know the resistance between 2 points in a circuit and the voltage that you're supplying to these 2 points of the circuit. So I'm going to use Ohm's law. I'm going to go to my calculator here. I'm going to use Ohm's law, voltage equals current times resistance. In my case here, I want to calculate the current, right? So I need to figure out what the voltage is and what the resistance is. Since this is a 5-volt coil relay, I know that the V is going to be 5 volts, so I just need to figure out what the resistance is. And for that, of course, I'm going to use the multimeter. I'm going to connect the coil pins, and there you go. So resistance is 72.3. I'm going to go to my calculator, leave 5 as it is, and then put 72.3 in here. And there you go. So the current that is being drawn is 69.15. So that's quite large, right? If you look at the specifications for the Arduino Uno, somewhere down here, it says, okay, maximum DC current draw is 40 milliamps. I went up to 70 milliamps, so I went way above even the maximum. So I'm lucky that my Arduino didn't burn. So I need to take that into account when I build the actual circuit. Now, before I do that, I'm going to do the connections the wrong way, the dangerous way, right? And then I'm going to modify my circuit to make the connections so that the Arduino won't be burned or damaged, right? So there is one more consideration, and that is the fact that the coil inside this relay stores electricity. So every time that I make the connection and energize the coil, a bit of electricity and electrical energy is stored inside the coil. When I switch off or when I release, well, when I de-energize the coil, that energy has to be released as well. When the coils are connected to the Arduino, then there is a danger that the energy that is stored inside the coil is going to flow back into the Arduino or whatever else you've got connected to these 2 pins. So I want to prevent that, and for that reason I use a diode. So the diode will prevent any back current from flowing into your Arduino or other devices like a transistor, as we'll see later. It's a protective device. So that's why in my test circuit, I'm going to use a diode like this to protect my Arduino. All right, enough with that said. So I'm going to, because I can't plug the relay directly into my breadboard, the pins don't align very well, and I don't want to damage the Arduino's, the relays pins. I'm just going to use alligator clips. Right, so it doesn't really matter what color you use, since, as I said, this is not a polarized device. So I'm going to use a white for that side, sorry, a red for that side, and a white for that side. I'm going to plug the diode in any way I just happen to plug it in, and then I'm going to connect the second set of clips, alligator clips, on the diode like that. Then I'm going to use a couple of wires to connect ground. Now you need to be careful, because the ground needs to go onto the side of the diode that doesn't have this white marking. So this white marking shows the polarity of the diode. So I'm going to connect the ground black wire on the side that doesn't have that white strip. And the other side is going to go onto pin number 13. So it's already drawing too much power. All right. Won't do this yet. I'm going to put it, actually I'm going to leave it hanging on the, without connection yet. So next I'm going to load a little sketch. I'm just going to take the blinking LED sketch and load that. And all I've got to do, all I want to do is to get the LED to switch on and off. In extension, what's going to happen is that the coil is going to be energized on and off. So, upload the sketch first. Now remember, this is the incorrect way of doing this, and I'm endangering my Arduino by doing this. But I just want to show you how it works before we move into the next step. So LED is blinking, so I'm going to plug this now. So you can hear a very faint clicking noise coming from the relay. So it's drawing a lot of power, about 70 milliamps now, which is a bit too much. Right now, I'm going to disconnect it so it don't cause too much strain on my Arduino. And what I want to do next is to bring in the second part of the circuit, the LED strip, the 12 volt LED strip. Now, these wires convey 12 volts. I'm going to plug this into power. All right, I've got power, and then I'll show you a bit crowded here. Let's see. I want to figure out where the polarity is in order to turn the LEDs on. Okay, it doesn't work this way. Because I can't see what the anode and the cathode is, I have to experiment with the LED strip. So that way it works. Right, so I want to make it so that the LED strip is controlled by the relay. So for that, I'm going to use another set of alligator clips. I didn't keep a mental note of the connections. All right, so that's not good. Okay, that's good. So I'm going to connect the red wire to the positive 12 volts directly into the power supply. Okay, and then I use my yellow alligator clip to connect, to connect the second side, the black wire of the LED strip very, very carefully to one of the secondary pins on the relay. Whoops. And I'll use red to connect it with either one of the two remaining pins on the relay. All right. And lastly, I'm going to connect the orange wire back to pin number 13. And there you go. Now we are driving the LED strip via a relay with our Arduino. All right. Disconnect so I don't cause any further strain, and I'm going to adjust the circuit so that now I draw only a small amount of current from the Arduino to drive this relay.